For example 2, we are going to write each function as an expression involving functions of theta. So we're going to start with sine of 30 degrees plus theta. We're going to use the sine of a plus b formula to expand that out to equal the sine of 30 degrees multiplied by the cosine of theta plus the cosine of 30 degrees multiplied by the sine of theta. So if you notice, that's our sine of a plus b formula. Then we're going to substitute in the values that we know from our unit circle. We know that the sine of 30 is 1/2, so we have 1/2 the cosine of theta. We know that the cosine of 30 is square root of 3/2, and that's multiplied by the sine of theta. And those are not like terms, so we could just stop there, so there's one possible answer. What some books will do is they will let them share the 2 as a common denominator, and then simply put 1 cosine of theta plus square root of 3 sine of theta on top. So that's another option for how the final answer may look. And then the calculus book that I use actually does this, which I think is really strange. They actually factor a 1/2 out. They put a 1/2, then they open a parenthesis and say cosine of theta plus the square root of 3 times sine of theta. So it's good to be able to recognize any of those options. I'll take any of the 3, so it doesn't really matter. Okay, now let's try to find the tangent of 45 degrees minus theta. Our expansion formula for that is tangent of a minus b equals tangent of a minus tangent of b all over 1 plus the tangent of a times the tangent of b. And if we substitute in, we know that the tangent of 45 degrees is 1. So we have 1 minus the tangent of theta for our numerator. And in our denominator, we have 1 plus 1 times the tangent of theta. And we have to be really careful here because we cannot combine these ones to make 2. Those are not like terms. That second one is attached to the tangent, and the order of operations will not let us do that. So our final answer is just going to be 1 minus the tangent of theta divided by 1 plus the tangent of theta. And because those 2 don't have radicals, we don't even have to rationalize or anything like that. We don't have to multiply by the conjugate. We can just stop there. So there we have that. Okay, so finally, part C. Part C is asking us to find the sine of 180 degrees minus theta. So that's the sine of a minus b. So we'll use that formula, the sine of a multiplied by the cosine of b, and then it will be minus the cosine of a multiplied by the sine of b. We'll plug in from our unit circle. We know that 180 degrees is our spot on the unit circle right over here, which has the ordered pair -1, 0. So the sine of that is 0. So we have 0 times the cosine of theta minus the cosine of 180 is -1. So minus -1 times the sine of theta. If we clean all of that up, 0 times cosine becomes just 0. So that part goes away. Then a minus times a negative gives me a plus sine of theta. So we have plus 1 sine theta. And so for our final answer is just sine of theta. So it turns out that the sine of 180 degrees minus any angle is actually equal to just the sine of that angle. And that's example 2.